Hello all, hope you are doing well. And in this video, we are going to see the important clauses in IS456 2000. So in IS456 2000, totally 5 sections are there. And among the 5 sections, in this video, we are going to see only the section 2. Okay. In this video, we are going to see the only section 2. And in the coming videos, we will also see the section 3, 4 and 5 also. So whatever the section 1 is there here, this section 1 deals with scope of the IS456 and the references for IS456. Then it gives the terminology and symbols used in IS456 2000. So there is nothing much to discuss about the section 1. So directly we are starting with the section 2. So in this video only section 2 will be there. In the coming video section 3, 4, 5 will be there. So let us start with the section 2 here, and first clause in the section 2, first important clause in the section 2 is 5.2.1.2 and next one is 5.2.1.4. Both the clauses deals with the mineral admixtures. Both of them are deals with the mineral admixtures. They are silica fume and metakaolin. So what is the purpose of these mineral admixtures is that they improves the strength of the concrete. The mineral admixtures improves the strength of the concrete. Now if you take the silica fume, you can use 5 to 10% of the silica fume out of the weight of the cement in concrete mix. Okay, so for the given concrete mix, you can use the silica fume only up to 5 to 10% out of the weight of the cement. Then if you take the metakaolin to be used in the concrete, its fineness must lies between 700 to 900 meters square per kg. Usually if you take the OPC, its fineness will be greater than 225 meters square per kg. But for the metakaolin, it is 3 to 4 times greater than that. That means metakaolin is a very fine material. Now when you use that very fine material in concrete, it fills the micro voids in the concrete, and because of that what happens, the strength of the concrete increases. These two clauses are 5.3.3 and 5.3.3.1, and these two clauses are related to the aggregate size. So aggregate size is generally prescribed as a nominal maximum size of aggregate, nominal maximum size of coarse aggregate. Then in case of any member, the nominal maximum size of coarse aggregate cannot be greater than 1/4 of minimum thickness. Okay, 1/4 of minimum thickness. Suppose if the thickness of the member is 100 mm, let us say minimum thickness of the member is 100 mm. Then whatever the maximum size of the coarse aggregate is there, that should not exceed 25 mm, like that it is. Okay, so the nominal maximum size of coarse aggregate in no case should be greater than 1/4 of the minimum thickness of the member. Then if you take a heavily reinforced concrete member, let us consider a heavily reinforced beam like this. Then in the beam at the bottom, the bars are like this. So whatever this distance is there between bars, that is called as clear spacing. That means end to end distance. That is called as clear spacing. Then whatever this cover is there, that is called as clear cover. Okay, whatever the cover is there, that is called as clear cover. Now in the case of heavily reinforced concrete members, okay, in case of heavily reinforced concrete members, the maximum size of the nominal maximum size of aggregate should be 5 mm less than clear spacing or 5 mm less than clear cover. Okay, should be 5 mm less than clear spacing or 5 mm less than clear cover. That means it should be clear spacing minus 5 mm or clear cover minus 5 mm. Okay, So minimum of these two values you have to consider. Okay, so the point is, in case of the heavily reinforced concrete members, whatever the maximum nominal size of aggregate is there, that should be minimum of clear spacing minus 5 mm and clear cover minus 5 mm. Then next class is related to the water used in the concrete. So whatever the water we use in the concrete, in that the organic solid should not be more than 200 mg per liter and inorganic solid should not be more than 3000 mg per liter. Then whatever the sulfates is there, it will cause the sulfate attack in the concrete. Okay, sulfates causes the sulfate attack in the concrete. So because of this sulfate attack, cracks are formed. That's why the sulfate content is restricted to the 400 mg per liter. Then whatever the chlorides are there, they will cause the corrosion of steel. Chloride causes the corrosion of steel. Now in case of PCC, this chloride content should not be more than 2000 mg per liter. But if you take the RCC, steel is there. So chlorides are very dangerous for the steel. That's why it should not be greater than 500 mg per liter. Okay, so whatever the PCC is there, for that chloride should not be more than 2000 mg per liter. For RCC, it should not be more than 500 mg per liter. Then suspended matter also should not be more than 2000 mg per liter. The next class is again related to the water here. So now as per this class, as per the class 5.4.1.2, suppose in the laboratory condition, we use the distilled water for mixing. Okay, in the laboratory condition, we use the distilled water for mixing. But in the site condition, in the field condition, can we use the distilled water? Not possible. So we use whatever the water available there. Now if you use the distilled water, maybe the strength obtained is high. So if you compare the strength obtained using the distilled water and the strength obtained using the available water, okay, strength obtained using the available water, that should be greater than 90% of strength obtained using the distilled water. That is what the clause 5.4.1.2 says. Average 28 days compressive strength of at least 3 concrete cubes. Okay, this is at least here. At least 3 concrete cubes prepared with water proposed to be. Okay, so whatever the water we are using for the 28 days compressive strength, you shall not be less than 90% of the average strength of 3 similar cubes prepared with distilled water. Okay, so that is the class. Then whatever the water we use, for that the pH value should not be less than 6. That means so whatever the water we use, that should be mostly alkaline in nature. Because if it is acidic in nature, then what is the problem? If it is acidic, then again it will cause the corrosion. Then next one is related to the steel we use. So the first point here is the modulus of elasticity of steel shall be taken as 200 kilonewton per mm square. That means 2 into 10 power 5 Newton per mm square. So whether it is Fe250 grade of steel or Fe415 or 500 or 550, whatever the type of steel it is, modulus of elasticity should be taken as 2 into 10 power 5 Newton per mm square. Then next one is related to the characteristic yield strength. Characteristic yield strength means nothing but grade of the steel. So this grade of the steel shall be assumed as a minimum yield stress or 0.2% proof stress. Suppose you consider the mild steel bars. Consider the mild steel bars. In case of the mild steel bars, stress strain curve will be like this. That means this is the stress here and this is the strain. So yield stress is taken at the lower yield point. Okay, yield stress is taken at the lower yield point and that is designated as the grade of the steel. This stress is taken as grade of the steel. But if you take the deformed bars, in that condition, you will not get the clear yielding point. You will not get the clear yielding point. Then in this case, what we do is, at the strain of 0.002, we will plot a offset like this. Okay, we will plot a offset like this. Then wherever this offset meets here, that stress is taken as F5. That stress is taken as yield stress. So this characteristic yield strength is taken as minimum yield stress. That means a stress at lower yielding point in case of the mild steel, or else in case of deformed bars, it is taken as the 0.2% of the proof stress. Strain is 0.002 here. That means percentage. If you consider it in percentage, it is 0.2%. So at 0.2% strain, whatever the stress is there, that is called as 0.2% proof stress. So that stress is taken as characteristic yield strength. Okay, next one is related to the grade of the concrete. So you know what is grade of concrete? Grade of the concrete means, what does the grade of concrete represents is, it represents the characteristic compressive strength. The grade of concrete represents the characteristic compressive strength. Then what is this characteristic compressive strength? Okay, suppose consider the M30 grade of concrete, and I have given mixed design like some 1:1.2:2.3. Like this I have given the mixed design. Now with this mixed design, I may get the strength of M30 Newton. I may get the strength of 30 Newton per mm square if the mixing is done properly and if the compaction is done properly. But in the field, the conditions are improper. Maybe that means mixing was not done properly, or else the compaction was not done properly. In that case, whether I will get the strength of 30 Newton per mm square for sure? Not probable. So the thing is, when I say characteristic compressive strength, at least we should have 95% probability to get a strength more than that value. Okay, to get a strength more than that value. That means when I say M30 grade of concrete, we should obtain the strength of 30 Newton per mm square at least with 95% probability, and not more than 5% of the result should be below that value. Okay, so when I say characteristic compressive strength, at least you should have 95% success rate. At least you should have 95% success probability. Then based on this grade of concrete, concrete is classified into three types. They are ordinary concrete, standard concrete, and high strength concrete. For ordinary concrete, grade of concrete will be M10 to M20, and for standard concrete, in the table you can see like M60. I mean, you can see the M60 here, but later it was revised in one of the amendment, and M60 is added to the standard concrete. So from M25 to M60, it comes under the standard concrete, and grades greater than or equal to M65, that comes under the high strength concrete. Okay, so what is the minimum grade of high strength concrete? That is M65. And M60 falls under which grade of concrete? A standard concrete. Then next class is related to the flexural strength or tensile strength of concrete in bending. Okay, flexural strength or tensile strength of concrete in bending. Both are same. Okay, so this value should be, this value is taken as 0.7 root FCK. Okay, 0.7 root FCK. Flexural strength of concrete is taken as 0.7 root FCK. And this flexural strength can be also called as modulus of rupture. So when I say modulus of rupture or flexural strength or tensile strength in bending, all the things are same. Okay, that value is how much? 0.7 root FCK. The next class is related to the modulus of elasticity. So here this modulus of elasticity is primarily influenced by elastic properties of the aggregate. That means whatever the elastic modulus of concrete is there, that mainly depends on what? Elastic properties of the aggregate. Elastic properties of the aggregate. And along with that, it also depends on condition of curing and the mix proportion and the type of cement. Okay, it also depends on the type of cement. And in the absence of test data, whatever this EC value is there, that is taken as, whatever the EC value is there, that is taken as 5000 root FCK. And remember that this 5000 root FCK and EC is called as a short-term modulus, short-term elastic modulus, or secant modulus. Okay, so if I ask you EC equal to 5000 root FCK is also called as, then it is the short-term elastic modulus or secant modulus. Okay, then in actual the EC value need not be 5000 root FCK always, but it will show the variation of plus or minus 20%. Okay, plus or minus 20%. That means it may vary between 4000 root FCK to 6000 root FCK. Okay, so actual value may varies between this, but for our consideration, in the absence of tested data, we will take it as 5000 root FCK. Next one is related to the shrinkage of concrete. This shrinkage of concrete depends on constituents of concrete. That means it depends on the type of cement and fineness of cement, these things. And along with that, it also depends on the size of the member and environmental condition. Environmental condition means it depends on humidity, temperature, these things. Okay, so shrinkage mainly depends on what? Constituents of concrete, size of the member and environmental condition. Now for the given environmental condition, that means for the given humidity and temperature, the total shrinkage is influenced mainly by two factors. Okay, first one is amount of water in concrete and second one is cement content. Okay, so if the humidity and temperature are constant, then shrinkage depends on amount of water in concrete and cement content, mainly on amount of water in concrete and at lesser extent on cement content also. Then next class is related to the workability required. So everyone knows what is workability. Workability is basically ease of handling the concrete. When I say handling the concrete, it involves many steps like mixing, placing, compacting, compacting and finishing these things. Now if you can place the concrete easily, it is highly workable concrete. If you cannot place it easily, then it is a low workable concrete. Suppose if you are working at higher depth, you are placing the concrete at higher depth, then placing of the concrete is easy or difficult? Placing of the concrete is difficult. So when the placing of concrete is difficult, whether we require the concrete of more workability or less workability? We require the concrete of more workability. But if you are working at a less depth, that means you are working on the ground only, then you require the concrete of less workability because placing is very easy. So now if you can see here, blinding concrete or shallow sections are pavement using pavers. Blinding section means concrete used in beds of foundation. So in that case, just we will spread the concrete to obtain a level surface. We will not keep any reinforcement also. Then in that case, we can place the concrete easily. So workability required is very low. And similarly, in case of shallow sections, shallow section means again it has very less depth. So placing of concrete is very easy. and pavement using pavers. In the three cases, we require the very low workable concrete. Then in case of mass concrete, lightly reinforced section, hand placed pavements, canal lining, strip footing, we require the concrete of low workability. Now, if the reinforcement percentage increases, here it is the lightly reinforced section, here it is the heavily reinforced section. Whenever the reinforcement increases, then placing of concrete will become difficult, because when it is heavily reinforced, it will be congested. It will be congested to place the concrete. So in that case, again, here placing the concrete is difficult. So we have to increase the workability from low to medium level. Then for slit work and pumped concrete, we require the medium workability. And for trench fill or in situ piling, that means you are working at very high depths. Whether it is the trench fill or in situ piling, we have to place the concrete at higher depth. In that case, we require the concrete of high workability. And next one is the trimmy concrete. That means you are using a trimmy pipe to send the concrete. That means concrete has to flow through the pipe. So in that case, we have to use the very high workable concrete. Okay, so like this, the workability required depends on the type of work we are doing actually and the placing condition of the concrete. Next one is related to this clause is related to the durability of the concrete. So this durability mainly depends on 6 factors here. First one is the environment. Environment. So environment in the sense, suppose in one case you are placing the concrete. In one case you are placing the concrete under a shed like this. Okay, this is the concrete now, and you are placing the concrete under a shed like this, shelter like this. And in another case, you are placing the concrete in the sea water. You are placing the concrete in the sea water. Whether both of them can last for same time if you use the same material and if you use the same mixing procedure? No, obviously, because here on concrete, the external effects will be very high. The effect of seawater will be very bad. So here the concrete deteriorate easily, so lifespan will be less. So the first factor on which durability depends is the type of environment in which you are placing the concrete. Second one is the cover of embedded steel. The cover of embedded steel. So now in one case, you are placing the steel here, so this is the cover. In another case, you are placing the steel here, that means cover is very less now. Now when the cover is very less, then moisture can come in contact with the steel easily. So what happens to the durability? Decreases. So you can say like if the cover increases, then durability increases. Next, the type and quality of constituent materials. So obviously if you use the good quality materials, then you will have good durability. So we don't need to discuss anything on that. Then next one is the cement content and water cement ratio of the concrete. Now in one case water cement ratio is 0.4, in another case water cement ratio is 0.6. So whenever the water cement ratio increases, what happens to the permeability? Increases. So here with increase in water cement ratio, permeability increases. If the permeability increases, then what happens to the durability? Durability decreases, because the permeability is high, then through the concrete anything can flow. So because of that, durability decreases. Then workmanship to obtain full compaction and efficient curing. Okay, full compaction and efficient curing. So if you are doing the compaction effectively, that means the voids in the concrete will become less. Okay, if you are doing the compaction effectively, then voids in the concrete becomes less, then durability obviously increases. If you are doing the curing efficiently, again the durability increases. Next one is the shape and size of the member. So whatever the shape you are casting, it should be in such a way that whenever the water comes, whenever the rain falls, suppose, okay, whenever the rain falls on the member, the water should easily flow from that. So if the drainage is good, then water will not store there, so obviously the durability of the concrete increases. So these are the 6 factors on which durability of the concrete depends on. Next one, table number 3. And in this table number 3, environmental exposure conditions are described. Let us see what are they. So suppose you are considering the normal rainfall. It's not severe, normal rainfall you are considering. In the if the normal rainfall is there and concrete is there in the non-coastal area, concrete is there in the non-coastal area, okay, these are the 2 conditions. Then if the concrete is sheltered, okay, in one case concrete is sheltered, in another case concrete is not sheltered, okay, whether durability will be same in both the conditions? No. That's why this condition is called as mild condition and this is called as moderate condition. Now you take the severe rainfall, suppose, okay, you take the severe rainfall, and when the severe rainfall is there, okay, when the severe rainfall is there, concrete is protected against concrete is protected with the shelter in one case and not sheltered in another case. So when it is sheltered, it is taken as a moderate condition because it is the severe rainfall, and when it is not sheltered, it is taken as the severe condition. Okay, those things you can see here. So mild condition, concrete surface protected against weather or aggressive condition except those situated in coastal area. Okay, this is not situated in coastal area, normal rainfall and non-coastal area. Then if it is sheltered, if it is protected, then it comes under the mild condition. Then concrete exposed to the condensation and rain. If it is not sheltered, that means then it comes under the moderate condition. Okay. Then concrete surface sheltered from severe rain. Okay, concrete surface sheltered from the severe rain. Then it comes under which condition? Moderate condition. If it is not sheltered, then it comes under the severe condition. That is what you can see here. Concrete surface exposed to the severe rain. That comes under the severe condition. Okay, then suppose concrete is there, concrete is immersed in the seawater. Okay, concrete is immersed in the seawater. And in another case, it is immersed in the normal water. So if it is immersed in normal water, then it comes under the moderate condition. And if it is immersed in seawater, then it comes under the severe condition. It comes under the severe condition. Suppose this is the port, let us say, this is the port area, and now the tides are hitting the port like this. Tides are hitting the port like this. This is the seawater. So some concrete is there in the seawater, and this is the concrete which is in contact with the tides, and there are some buildings at a distance of some 100 meters. Now whatever the concrete is immersed in the seawater, that comes under the severe condition. Then some of the water, because of the waves here, some of the water that will come as spray, and this spray consists of bubbles. The spray consists of bubbles. Then whatever the bubbles are there, when it comes on contact with a surface like this, it will blast on the surface. Okay, it will blast on the surface. So it will show more effect. The seawater spray will show more effect than the seawater, than the concrete under the seawater. So this is more dangerous. This condition is more dangerous. So this comes under the very severe condition. Now whatever the concrete is there here, this is continuously hit by the tides like this. That's why this condition is taken as, okay, this condition is taken as extreme condition. So these three things you can see here. Concrete completely immersed in the seawater, severe condition. Concrete surfaces exposed to the seawater spray, very severe condition. Then surface members in the tidal zone, that comes under the extreme condition. Okay. Then suppose concrete is buried under the non-aggressive soil. Okay, concrete is buried under the non-aggressive soil. Then it comes under the moderate condition. And if the concrete is buried under the aggressive soil, okay, concrete is buried under the aggressive soil, then it comes under the very severe condition. If the concrete is not buried, if the concrete is buried under the aggressive soil, then it is very severe condition. If it is buried under non-aggressive soil, then it comes under the moderate condition. Then whatever the members in direct contact with liquid and solid aggressive chemicals are there, that comes under the extreme condition. Okay, so these are the different exposure conditions. Then clause number 8.2.2.3. Now whenever there is freezing and thawing condition, to resist that effect, what we have to do is we have to entrain the air in the concrete. Okay, whenever there are freezing and thawing condition, we have to entrain the air in the concrete. So now if you are using the concrete grade less than M50, okay, if you are using the concrete grade less than M50, and if the nominal maximum size of aggregate is 20, air entrained is 5 plus or minus 1%, and if it is 40 mm aggregate, air entrained must be 4 plus or minus 1%. Then to make the concrete durable, the weight of the cement, okay, the weight of the cement per 1 cubic meter should not exceed 450 kgs. So when I say cement, it should not consider the fly ash and GGBS here. We should consider exclusive of the cement content. So that content should not exceed 450 kg per meter cube in order to get the durability. Then based on this exposure condition, we have to decide what is the minimum cement content we have to use, what is the maximum free water cement ratio we have to use, and what is the minimum grade of concrete we have to use. So these are given in table number 5, and these are suitable only for the 20 mm nominal maximum size aggregate. Okay, so in the table number 5, what is given? Minimum cement content, maximum free water cement ratio, minimum grade of concrete for both plain concrete and reinforced concrete. Okay, so these values, whatever the values given here, they are suitable for the 20 mm nominal maximum size of aggregate. Now if you take the mild condition and plain concrete, the minimum cement content we have to use is 220 kg per meter cube, and maximum free water cement ratio you can use is 0.6. So you have to understand that the maximum free water cement ratio we can use in any condition is 0.6, and beyond that we should not use. Then there is no minimum grade of concrete, like you can use M10 grade of concrete, M15 grade of concrete, whatever you can in case of the plain concrete. But if you are using the RCC, okay, then minimum grade of concrete required is M20. Very, very important question. The minimum grade of concrete used in RCC is M20, and the maximum free water cement ratio is 0.55, and minimum cement content is 300. Okay, so at least remember it for the mild condition. Okay, for mild condition it is very, very important. So in the mild condition, minimum cement content is 220 kg per meter cube, maximum free water cement ratio is 0.6. Whereas in the reinforced cement concrete, minimum cement content is 300 kg per meter cube, maximum free water cement ratio is 0.55, and minimum grade of concrete is M20. Okay, now if you are using the aggregate size other than 20 mm, okay, if you are using the aggregate size other than 20 mm, that means if you are using 10 mm aggregate or 40 mm aggregate, then in case of 10 mm aggregate, we have to increase the cement content by 40 kgs. Okay, this is the adjustment to minimum cement content. So here this 220 kgs is for 20 mm aggregate, but if you are using the 10 mm aggregate, you can increase it by 40 kgs. Whereas if you are using the 40 mm aggregate, then we have to reduce it by how much? 30 kgs. Okay. Then another important effect in case of the concrete is alkali aggregate reaction. Alkali aggregate reaction. What is this alkali aggregate reaction is? So whatever the cement is there, it consists of some alkalis. Okay, whatever the cement is there, it consists of some alkali content. Then whatever the aggregate is there, sometimes they may be reactive in nature. If it is non-reactive, it's not a problem. But if it is reactive in nature and if the cement consists of alkalis, then this alkalis react with the aggregate and that causes the swelling in the concrete. Okay, that causes the swelling in the concrete, which is called as alkali aggregate reaction. So this alkali aggregate reaction is because of the alkalis which are N2O and K2O. And this alkali aggregate reaction happens under three conditions. If these three conditions are there, then only it will take place. First one is the high moisture level, second one is the high alkali content, and third one is the aggregate containing an alkali reactive constituent. Okay, so aggregate must be reactive in nature, cement must contain alkalis, and there must be high moisture level. Then only alkali aggregate reaction happens. So next class is related to the concrete in seawater. So whenever you are placing the concrete in seawater, if you are using it for the purpose of plain concrete, okay, if you are using it for the purpose of plain concrete, then we have to use minimum of M20 grade of concrete. Okay, in case of plain concrete, if it is minimum of M20 grade, and if it is RCC, okay, if it is reinforced concrete, then you have to use minimum of M30 grade. Okay, see this, if you are using the concrete in the seawater, then if you are using the PCC, minimum grade of concrete is M20. If you are using RCC, then it is minimum M30. Next one is class number 9.3. As per this class number 9.3, we can use nominal mixes. We can use nominal mix concrete only up to the grade of M20 or lower than that. Suppose if it is M25, M30, we should not use the nominal mixes. Instead, we have to go for the design mixes. Okay, so nominal mixes are allowed only till M20 grade of concrete. Then whatever the nominal mixes are there, their proportions must be like this. Okay, so as you can see, M5, M7.5, M10, M15 and M20 are there. And in that cases, for each cement bag, for 50 kgs of cement, you can use 800 kgs of fine and coarse aggregate together. Okay, so 800 kgs of aggregate we can use for M5 grade of concrete, 625 kgs for M7.5, 480 kgs for M10, 330 kgs and in M15, 250 kgs in M20. So these are for 50 kgs. This is cement and this is aggregate. Okay, now whatever the aggregate proportion is there, that should be generally taken as how much? 1:2, but subjected to an upper limit of 1:1.5 and a lower limit of 1:2.5. So whatever that proportion is there, that varies from 1:2.5 to 1:1.5. Okay, so usual value is how much? 1:2. Suppose if you are making the M5 grade of concrete, the total weight of aggregate can be 800 kgs. So this and 800 kgs we have to distribute in the proportion of 1:2 for fine aggregate and coarse aggregate. Okay, so like this we have to do. Now as I said, this is varying from 1:2.5 to 1:1.5, 1:1.5. So if it is 10 mm, if the coarse aggregate size is 10 mm, then we can take the proportion of 1:1.5. If it is 20 mm, then we can take 1:2, and if it is 40 mm, then we can take 1:2.5. Okay, so if you are using 10 mm coarse aggregate, then distribution of aggregate should be like 1:1.5, 20 mm 1:2, and 40 mm 1:2.5. Okay, like that, with increase in the size of coarse aggregate. Okay, with increase in the size of coarse aggregate, we can increase the proportion of coarse aggregate. Okay, so that is about the nominal mix. Then next class is 10.2.2. And this class is related to the accuracy of measuring equipment. Now while measuring the cement, okay, while measuring the cement, the accuracy of the equipment must be plus or minus 2%. If you are measuring the sand admixture, water and coarse aggregate, then accuracy must be 3%. Accuracy of the instrument must be 3%. So while measuring the cement, accuracy must be 2%. While measuring the remaining materials, accuracy must be 3%. Then whatever the mixing time is there, okay, whatever the mixing time is there, that shall be at least how much? 2 minutes. Okay, so in case of concrete, the minimum mixing time required is 2 minutes. Then the dosage of retarders, plasticizers and superplasticizers, they shall be restricted to 0.5, 1 and 2%. So if it is retarder, the maximum percentage can be 0.5% out of the weight of the cement, and if it is the plasticizer, it is 1% out of the weight of the cement. If it is super plasticizer, then it is 2% out of the weight of the cement. Okay, then next class 11.1 is related to the formwork. So here it gives the deviations for the formwork. Okay, this provision gives the deviations for the formwork. Now when you are using the formwork for columns and beam, okay, when we are using the formwork for columns and beam, then the deviation can be plus 12 mm. The deviation can be within the range of plus 12 mm or minus 6 mm. Suppose the beam width is 300 mm, let us say. Then whatever the form we use, further the size should be up to 12 mm, okay, plus 12 mm. That means it should be 312 mm, or else minus 6 mm. That means it should be greater than 294 mm. So form size should be 294 to 312 mm in case of the beams and columns like this. But if you are using it for the footings, okay, if you are using it for the footings, then it may be plus 50 mm or minus 12 mm, in the range of plus 50 mm or minus 12 mm. Similarly, whatever the eccentricity is there, okay, whatever the eccentricity of that form is there, that is how much? That is 0.0 times the width of the footing in the direction of the deviation, but not more than 50 mm. Okay, so whatever the eccentricity is there, that can be how much? 0.0 times the width of the footing, but in no case it can be greater than how much? 50 mm. Then whatever the thickness is there, that should be in the range of, whatever the deviation in thickness is there, that should be in the range of plus or minus 0.05 times. Okay, this is related to the formwork. Then next one is the minimum period before striking formwork. Okay, that means after placing the formwork, you cannot keep it throughout the throughout the life of the period. So in that case, suppose if it is vertical formwork, okay, if it is vertical formwork, then we have to remove it after, we can remove it after 16 to 24 hours. Okay, we have to remove it after 16 to 24 hours. Then if it is the soffit formwork means formwork at the bottom. Okay, vertical formwork means formwork at the sides. Suppose this is the beam. This is the beam, let us say. Then whatever the formwork is here, whatever the formwork we place here, that is the vertical formwork. And whatever the formwork we place here, that is the soffit formwork. Okay, so all the vertical formwork for columns, walls and beams, that can be removed after 16 to 24 hours. And if it is the soffit formwork, if it is this soffit formwork to the slabs, if it is soffit formwork to the slabs, that can be removed after 3 days. Okay, soffit formwork can be removed after 3 days. But once if you remove the soffit formwork here, we have to replace it with props like this, because still it may not support the load, so we have to place the props there. And this soffit formwork to the beams, okay, this soffit formwork to the beams, that can be removed after 7 days. So soffit formwork to the slabs can be removed after 3 days. Soffit formwork for beams can be removed after 7 days. Then whatever the props left over here, okay, whatever the props left over here, in case of slabs, if the span is less than 4.5 meter, okay, the span is less than 4.5 meter, then you can remove after 7 days. If it is greater than 4.5 meter, you can remove after 14 days. Then for props to the beams and arches, if the span is less than 6 meter, you can remove after 14 days. If it is greater than 6 meter, you can remove it after 21 days. And remember one condition here, when you are removing the formwork, okay, when you are removing the formwork, whatever the when you are removing the formwork, whatever the strength of concrete is there, okay, whatever the strength of concrete is there, that must be at least twice of the strength of the concrete while removing formwork. While removing formwork, it must be at least twice of the stress in concrete because of loading. Then only we can remove the formwork. Otherwise, we have to wait for a few more days. Okay. Then whatever these rules are there, they are applicable when the temperature does not fall below 15 degrees centigrade. And next one is regarding the position of the reinforcement. Okay. So for effective depth up to 200 mm or less, the tolerance in the position of the reinforcement can be plus or minus 10 mm, and if it is greater than, if the depth is greater than 200 mm, then it is plus or minus 15 mm. Okay, so this is regarding the position of the reinforcements. So suppose the beam is there like this, and here we are placing a beam. Sorry, here we are placing a bar like this. Then whatever the position of the bar is there, that should not be shifted at a distance not more than plus or minus 10 mm in case of depth less than 200 mm. If it is greater than 200 mm, it should not shift to the distance more than plus or minus 15 mm. Okay. Next one regarding the actual concrete cover. So whatever the concrete cover we provide, okay, whatever the concrete cover we provide, that should not be more than 10 mm from the required nominal cover. Suppose required nominal cover is 40 mm. Then whatever the cover we provide, that should not be more than 50 mm, like that it is. So this is the required, this is the actual concrete cover. So actual concrete cover should not deviate by plus 10 mm from the required nominal cover. Next one is regarding the permissible free fall of concrete. So in no case concrete should not fall from a height more than 1.5 meter, because if it falls from a height more than 1.5 meter, if it falls from a height more than 1.5 meter, then by the time it reaches the ground, what happens is concrete will be subjected to the segregation. So the maximum time of falling is, maximum height of falling is how much? 1.5 meters. Next one is regarding the curing. So what is curing? We know curing is basically preventing the moisture in the concrete, preventing the loss of moisture from the concrete. Okay, if the moisture is not there in the concrete, concrete will be subjected to shrinkage and it cannot obtain the required strength also. Okay, so for that purpose we have to do the curing, and curing is the process of preventing the loss of moisture. Okay, then this curing has to be done to particular duration depending on the type of the cement we use, and along with that in which way we are doing the curing. Okay, so in case of curing, in case of moist curing, you can do the curing by ponding or covering, or else we can directly spray the water. So if the concrete in damp or wet condition by ponding or covering, then minimum duration of curing is 7 days if you are using only OPC. If blended cement or mineral admixture are there, then you have to cure for 10 days. If the concrete is in the dry and hot weather condition, that means there is no ponding, there is no covering with water. In that case, you have to do the curing for 10 days if you are using only OPC, and you have to do it for 14 days if you are using blended cement or mineral admixture. Next one is class 15.2.2. So this class 15.2.2 gives the frequency of the sampling. Okay, it gives the frequency of the sampling. Now when you are working in the site, suppose if the volume of the concrete you are working is 1 to 5 meter cube, then minimum number of samples we have to take is 1. And here when I say sample, each sample should minimum consist of 3 cube specimens, or else 3 specimens if it is not the compressive strength. Okay, so each sample should minimum consist of 3 specimens, and when I say one sample here, that means 3 specimens are there. Okay, so if it is 1 to 5, then it is 1 meter cube. If it is 6 to 15 meter cube, if it is 1 to 5, then it is 1 sample. If it is 6 to 15, then it is 2 samples. If it is 16 to 33 samples, 31 to 50 meter cube, 4 samples, and if it is 51 and above, then 4 plus 1 additional sample for each additional 50 meter cube are part thereof. That means, suppose I am taking 70 meter cube concrete, then it is 50 meter cube plus 20 meter cube. So for first 50 meter cube, you have to take 4 samples. Then for next 50 meter cube are part of that. Okay, for next 50 meter cube are part of that, we have to take 1 additional sample. So if it is 70 meter cube, totally we have to take how many samples? 5 samples we have to take. Suppose you are taking 160 meter cube, then it can be written as 50 plus 50 plus 50 plus 10. For first 50 meter cube, how many samples you have to take? 4 samples. Then next for 50 meter cube, 1 sample, next 50 meter cube, 1 sample, and next 50 meter cube are part of that, it is 1 sample. So totally we have to take 7 samples. So like that we have to collect the sampling for testing procedure. Okay. Now while determining the compressive strength, we have to check each sample. We have to test each sample, and when I say sample, it consists of how many cubes? 3 cubes. Okay. Then we have to determine the average of the strength of 3 specimens. We have to determine the average strength of the 3 specimens. The individual variation should not be more than plus or minus 15% of average. The individual variation should not be more than plus or minus 15% of average. So what is that? We will see now. Okay, now suppose you have tested 3 cubes and you got the compressive strength like this, 20, 25 and 30. Now what is the average of that? 25. So now compare 20 and 25. This is the average value and this is the individual specimen strength. So this variation is how much? 25 minus 20 by average, 25 into 100. That gives you 20%. So variation is more than 20%. So this kind of result is invalid. Okay, if more, the test result of the sample are invalid. So whatever the individual sample strength is there, that should not be varied more than 15% by the sample strength, sample average strength. That's the condition. So if it is less than 15%, then only it should considered as sample. Otherwise it should be rejected. It should be invalid. Then for the characteristic compressive strength, the code is giving a requirement here. Now it is valid for M15 or above. So in this case, if you take the 4 sample test results, okay, if you take the mean of the 4 non-overlapping consecutive test results, okay, I am saying mean of the group of 4 non-overlapping consecutive test results, then it has to be like this. On day 1 you have taken 1 sample. 1 sample means how many cubes are there? 3 cubes. Cube 1, cube 2, cube 3. Next day 2 you have taken another 3 cubes. That means another sample it is. So this is sample 1, this is sample 2. Like this, minimum how many samples you have to take? Maybe and day 2 you are taking another sample because you are doing more concrete work on that day. Cube 1, cube 2, cube 3. And day 3, sample 4, cube 1, cube 2, cube 3. So like this, if you take the 4 sample test results, then we have to determine the mean of these four. Okay, we have to determine the mean of these four. Now whatever the mean value is there, okay, whatever the mean value is there, this should be greater than FCK plus 0.825 sigma or FCK plus 3 Newton per mm square, which is greater. Okay, so you have to check what is the greater among these values. Then whatever the mean of these four values, mean of these four samples is obtained, that should be greater than these two values here. Okay, so then we can say that it is following the criteria. And if you check the individual sample strength, okay, if you check the individual sample strength, this is the individual sample strength, and this should be greater than FCK minus 3 Newton per mm square. Okay, that's what you can see. Okay, so individual test results should be greater than or equal to FCK minus 3, whereas mean of the group of 4 non-overlapping consecutive test results should be greater than or equal to FCK plus 0.825 sigma or FCK plus 3, whichever is greater. So like that is. Okay, so these are the important clauses in section 2, and in the next video we will discuss the important clauses in the section 3. Okay, so whatever the section 2 we have seen, in any type of competitive exam except GATE, you can see at least 1 or 2 questions. Minimum you can see 1 or 2 questions. Okay, so hope you enjoyed the video, and if you like this video, you can subscribe to our YouTube channel as well as Telegram channel, and that links are given in the description.